So the next section that we're going to talk about are intervals. So this is still section 1.1, but now we're talking about intervals. So first off, what are intervals? Intervals are just another way to write sets. So you know what a set is. A set is something that contains a lot of smaller elements, so maybe the set of real numbers or the set of whole numbers. If you want to express a set, you can write it explicitly. So you can express a set explicitly with brackets. So I could have something like that, or use an interval. So we'll go over both of them. First, let's talk about set notation. So if I want to say the set of all numbers, all real numbers that are between 2 and 5, how would I write that? First, I would use an open bracket, so set. I would say x in the real numbers, so this little symbol here, which is like an E, this means element of. That's how you want to read that. So I'm saying x is a member of, or x is an element of, real numbers, such that x is between 2 and 5. So that's how you would explicitly write this set. You would say this is the set of all x that are real numbers, such that x is between 2 and 5. Let's say I want to look at the set of all real numbers, such that, let's say, x is greater than 2. Maybe equal to this time. So this is a different set. So these are how you could write sets. This is saying all x such that x is a real number, such that this is true. Now sometimes we get a little bit sloppy, and we'll just write x such that x is greater than or equal to 2. It's kind of understood that x is a real number, so it's not necessary that you write x is a real number. You can sometimes just write x. Either way, this is acceptable, but this is what set notation is. It's saying I want the set of all x's such that something is true. So this part here is the something that's true. Up here I want x between 2 and 5. Here I want x greater than 2. And this little sign here means element of. So that's how you write a set. Now as far as intervals go, we want to express these sets as intervals. There are two kind of ends to intervals. We can either have open brackets, or we can have closed brackets. So this first one is going to be your open brackets. The second one is going to be your closed brackets. So we'll put that here. These are open. These are closed. So this is called an open interval. This is called a closed interval. Open interval means don't include the endpoints. So don't include endpoints. Whereas closed intervals, this means include endpoints. So that's the difference between open and closed. So open intervals, those are parentheses. That means don't include the endpoints. Closed means do include the endpoints. So sometimes you'll have half open or half closed. That just means you're going to include one endpoint and not the other. So if I had something like this is half open or half closed, doesn't matter. This means don't include A, but include B. So you can see how this is working. Brackets mean include it, parentheses means don't include it. So those are your intervals, those are all your endpoints. So how do you actually write this? So let's say I'm looking at this picture, have my real number line here, and I have my A and B. The interval from A to B means every number between those two values. That's what the interval means. So the interval from A to B is the set of all x such that x is between and including the two endpoints, so A to B. That's what this interval means. So anytime you see an interval with brackets like this, it means all the numbers between A and B, including the two endpoints A and B. If I look at my open intervals, it means everything between the two, but don't include the endpoints. So the interval from A to B That's all x such that x is between a and b, but don't include the 2. So I don't have less than or equal to, I just have less than. I do want to mention there's a different way to draw this. Sometimes you see the brackets as just closed dots, so like this, and then you'll see the open brackets as open dots. So these two pictures are kind of synonymous. Brackets will have a closed dot, parentheses will have an open dot. This just means don't include A, don't include B. This means include A, include B. You can go back and forth as to which one's easier. I'm not going to use one over the other, but that's kind of how you want to look at this. So for example, let's write the interval, let's say -1 to 3 as a set. So set notation means I'm going to have those kind of curly brackets. Let's maybe draw a picture first to represent what this is. So here's my real number line. I have -1 here, have 3 here. I want to include everything, everything between the 2. So this is the picture that I'm looking at. I'm trying to write this as a set. So if I'm going to write this as a set, I'm going to say this is my set of all x such that something is true. So what values do I want to bound x by? Well, on the left, the lowest value is -1. Can I be equal to -1? Well, yes, because I used a bracket, so I'll be less than or equal to there. What's my upper bound? That would be 3. Can I be equal to 3? Yes, because it's a bracket, so that's my set. Let's do one more of these. Let's write, how about 3 to 10? So open bracket on the 3, close bracket on the 10 as a set. Well, maybe let's draw the picture just so we know exactly what's happening here. So here's my 3. I'm going to put an open dot there so we can use both notations. A closed dot at the 10. And then we're looking at everything between the 2. Let me move this up a little bit. Hopefully you can still see that. Now if we're going to write this in set notation, I'll first write my interval. In a set notation, I'm looking at all x values here such that something's true. Look to your left first. What's the smallest number? Well, that's a 3. Can I be equal to 3? No, because I have an open circle here, so it's just strictly less than x. What value do I have to the right? That's a 10. Can I be equal to 10? Yes, because it was closed. So as a set, that's what I'm going to be looking at. So going from an interval to a set, you can either draw the picture and then go from there, or you can just say, you know, it's the values there and then let the brackets and the parentheses tell you. So parentheses, I don't include the equal, bracket, I do. What about this set? So what about the set of all x such that x is greater than or equal to 2 as an interval? So this time, I'm not starting with an interval and going to a set. Now I'm starting with a set, and I'm wanting you to write that as an interval. So let's look at this picture. Here's my real number line. Here's 2. I want a closed dot at 2. And then I'm looking at all x greater than it. Well, if I'm going to write this as an interval, I do the same thing I've been doing. What's the leftmost point? So here's my set. X is greater than or equal to 2. My leftmost point is 2. Should I include 2 in this set? Yes. So I put a bracket there. Now what's my rightmost point? Well, I don't have one. So whenever you don't have a rightmost point, you're going to say infinity. Now can I ever be equal to infinity? No, never. Infinity is an idea, it's not a number. So infinity is always going to have parentheses, never a bracket. So the set of all x such that x is greater than 2 is the same thing as close bracket 2 to infinity. Another example, let's say I want to write the set of x such that x is less than -1 as an interval. Now you don't necessarily have to draw the picture, I just think it might be easier for us to look at the picture. So here's -1. I should not include -1 because it's strictly less than, but I want everything less than it. So if I'm going to write this as an interval, first thing I want to do is say, what is my leftmost value? So if I go to the left, is there one? Well, there's not. So if there's not a leftmost, I'm going to have negative infinity. Again, you can't be equal to negative infinity. It's just an idea. So I'll say negative infinity. What's my rightmost point? That would be -1. Can I be equal to -1? No, it has an open circle around it, so that's my interval. So that's how you go from a set to an interval, is you just ask yourself, what's the leftmost point, what's the rightmost point, and that's kind of what you do. Let's see, let's do one more example of this. Let's express the interval 3 to infinity as a set. So this will be the last thing that we do in this section. So now I have an interval, it's involving infinity, let's write it as a set. Just to make sure we really understand what's going on, let's draw the picture. So I'm looking for all my x values from 3 on. Should I be equal to 3? No, I don't have a bracket. And I want to go on forever. So if I'm writing this as a set, I'm going to write my interval just like I was doing before. The set of all x such that something's true. So before, when we were doing this, we would say, what's our leftmost value, what's our rightmost value? We don't really want to write less than infinity. That's not proper notation. So here we just say 3 is my leftmost value, and then there isn't one. So this is x set greater than 3. If you want to write this a little bit easier, you could say this is all x such that x is greater than 3. That's how you would write this as a set. So set and interval notation are very similar. You can either express one in terms of, you can do either one of them. It doesn't necessarily matter which one you do. You just want to be comfortable with both of them. Also, as far as the is an element of, if I want to say something is an element of in this set here, I would say 10 is an element of 3 to infinity. It means 10 is in this set because 10 is greater than 3. I could also say, I don't know, 101. Also in this set, because 101 is greater than 3. Also in this set, 3.01. So that's how you use this, is an element of or is a member of. It just means that whatever number you write here has to be in the set. So that's going to be it for intervals and sets.